Okay, picking up on our last video, just kind of notice we made the power flow go in. So I want to point this out. Notice that our A phase over here now is 180 degrees out from this over here, and as well as B and C. We're going to talk more about that. Just want to point that out to you. But before I go any further, we're going to make the power flow go out again. So remember, I'm going to come up here and we'll put something in that's going out. And we're going to keep it at unity power factor for a minute, and we're going to put minus 120 here. And you can see everything changing there. So now what I want to point out to you that you need to pay attention to. So our CT ratio was 600 to 5 and 120 to 1. So with 100 amps, and if 120 is 1 amp, then 100 is going to be something less than 120. So 100 divided by 120 is going to give me these values of 0.833. They're all the same, and you notice the angles are just like what we entered in up here. And when you add these together, when all these angles get added together at this point, they add up to 0. And I want to point that out to you. So I'm just going to introduce to you this right now, but 100 at an angle of 0, if we convert that to a rectangular format, we get this, and I'm going to show you probably next video. B phase would come out to this, and C would come out to this, which gives us an X and Y coordinate. If I sum all the X's together, I'm going to get 0. If I sum all the Y's together, I'm going to get 0. So now I have a new X and a Y coordinate that sums to 0. And when I convert these back to what we call a polar value, which is a magnitude and an angle, then I'm going to get basically nothing here because there is no unbalance. We'll get to more of this in the next video.